so we can look at the piston robot and see potential pinch points. The structures that give rigidity to the robot are aluminum frames, and they're strong enough and made of a material with enough weight, and that the pistons have to have enough power in the pistons to be able to move the robot, and this is enough power to generate a scissors-like action. In addition, the possibility exists because of the range of motion that we've given the leg of the piston robot. The leg can actually move the foot in a way where the foot comes away from the robot far enough that the foot could actually hit a person. It could hit a person in their knee. Actually, the piston robot that we have designed, the foot could actually hit a person in their chest or their face. You need to remember again that this foot is made completely of aluminum, and if there was a programming error or a control error or a runaway series of steps, the piston robot could clearly kick a person right in the face. This would be a potentially devastating injury. And so again, we are bringing in a safety set of remarks to say that in terms of creating the piston robot, you must have appropriate understanding of the safety issues. In terms of actually reading about Piston Robot on the Piston Robot website and creating one, we need for you to understand that you are, by creating a piston robot that's real, you are creating an object that can hurt somebody. And we want you to understand that if you create that object, then you are responsible for it. At the risk of being redundant, we're going to emphasize this one more time, that whoever creates and maintains control of a structure, they are responsible for that structure. If they create and control a structure that is powered up and moving, they must enforce, create, and pay attention to a reasonable safety program that exists for the purpose of ensuring that nobody gets hurt by this physically real structure that they created. Okay, enough of the safety discussion. We just needed to emphasize that to you because it's really important. The first sentence or paragraph of any discussion of a three-dimensional drawing space is to just bring out the idea of how it exists. The three-dimensional drawing space that we use in SketchUp is the SketchUp space. For example, we have this three-dimensional drawing space here. It has axes to demonstrate where objects are in that space. If we created a new space that's empty, this space is going to have a defined set of decisions about how it's put together and what dimensions and conventions we use for writing in this space. Most of the SketchUp drawings have their own predefined template that they're created in, and each of those templates has, again, a series of conventions of what type of drawing convention we will be using, what type of drawing convention we will be using for the purpose of loading out dimensions or writing on the drawing, or when we measure structures or create movements, what controls how this movement and creation of objects is handled by SketchUp. Inside of this three-dimensional space of SketchUp is a set of axes. Because three dimensions exist in three separate axes, most people would see these as a y-axis that goes up and down, and really an x-axis that goes off to the right, and a z-axis that comes out towards you. The issue of axes is fairly complicated in real three-dimensional drawing because people have a way of handling access issues in their mind that if we're not careful how we think about it, we can become confused. There's a possibility our computer may have a little blue alien living inside the computer. We asked him if he would help us to show you the name of the next video in our series about PistonRobot. And he said, sure.